The most common measurements performed on MultiProbe AFPs are DC characterizations. MultiProbe AFPs have their own current voltage control software, called IVC, which controls any parameter analyzer through a GPIB connection. The user is able to map the multiple AFP probe heads to the parameter analyzer's SMUs on the fly through the head to SMU configuration. The user can also change SMU type and range settings depending on their hardware configuration. Applied source, compliance, and minimum and maximum range may also be set. Each range setting has a source and measurement accuracy and resolution. Common DC measurements for transistors are preloaded into IVC. The user can also load experiments from other multi-scan sessions or create a new experiment. The user has several options to modify in each experiment. There are two variables the user can set. Variable 1 is a sweep and variable 2 is a step. The parameter analyzer measures every point in the sweep, then moves to the next step and measures each point in the sweep again. An example: in a family of curves, for each gate voltage step, the parameter analyzer sweeps the voltage on the drain. After sweeping the drain voltage, the next step in the gate voltage is set, and the PA runs the voltage sweep on the drain again. In addition to these two variables, the user is able to use variable 1 prime. Variable 1 prime is the same as variable 1, and lets the user run the variable 1 sweep on two different nodes. The user can also set a ratio, where a 1/2 ratio sweeps variable 1 prime from 0 to half a volt with the same number of data points. IVC also lets the user set hold, delay, and integration times for the parameter analyzer. The hold is the amount of time after variable 2, the step, is set until the parameter analyzer starts the variable 1 sweep. The delay is how much time after setting a voltage in the variable 1 sweep before the parameter analyzer measures the current. Every variable 1 set point has a delay time. Every variable 2 set point has a hold time. The integration timing refers to the measurement itself, how much filtering and analog to digital conversion the parameter analyzer does at each measurement point. Increasing these timing values can increase measurement accuracy at the expense of a longer measurement time. At the bottom of IVC is the probe setup for the measurements. Users can designate which variable to run on which transistor node, drain, source, gate, or other, and which head to use for which node. This is also where the user chooses to force voltage and measure current, or force current and measure voltage, and which nodes to measure from. On the far right are columns for setting a constant bias and the SMU measurement compliance. When it is time to run measurements, the user has the option of running a single measurement or repeating it, clearing or appending the data on the graph, and running one or a sequence of measurements. When sequence is selected, IVC will run each measurement to the right of the first selected measurement, starting from the selected measurement. You can choose a group of experiments to show in order to select the desired sequence of measurements to run. This is helpful when selecting between N and P type transistors or different kinds of devices.